Hush.
Why do we enjoy jumping on the bed rather than on the floor? Or sitting on cushioning sofa is enjoyable rather than the floor. Also, we experience a smooth journey in our car. This is because spring present in all of them. Today, we will learn about spring force. Spring force is a pulling or pushing force that acts opposite to elongation or compression. Hooke's law says F is equal to negative of kx, where F is spring force, k is spring constant, and x is elongation or compression in the spring. The negative sign indicates that spring force act opposite to elongation or compression. This is the graph of spring force and elongation or compression. In this graph, slope is minus k. Now, how to find elongation in the spring when an object is freely suspended and the system comes at equilibrium? We have to just balance the forces at equilibrium. Therefore, spring force must be equal to mg. And from there, we can easily get the value of x, which is mg divided by k. Now in the same situation, if we have to find out the maximum elongation, for maximum elongation, we can not compare the forces because when spring is most stretched, then the system will not be in equilibrium. So, we have to use energy conservation. Work done by non-conservative force is equal to 0, therefore the sum of change in potential energies is also 0. The potential energy of spring is half of kx square and gravitational potential energy is mgx, and they both are in opposite directions, therefore a negative sign. And now by simple mathematics, we can solve for x. Okay, now, let us talk about spring's constant. It tells us about the stiffness of the spring. More the value of k, the harder it becomes to stretch or compress. It is inversely proportional to the length of spring. Grouping of springs. We can group springs in two ways. 1. Series grouping. This looks like as in the video, and the formula of K effective is also visible on screen. 2. Parallel grouping. This also looks like as in the video, and the formula of K effective is also visible on the screen. In parallel grouping, the formula of K effective is simple. We have to just add up the spring constants. Note that, in the case of resistance, that we study in DC circuits, in series and parallel the formulae get opposite. Anyways, now let us see the challenger question, which will be easy this time. You have to find the K effective for the given case. I know this question is easy. But wait for the next video, which will include questions practice on spring force. That will be great. Thanks for watching. Like this video, share it with your friends and please subscribe to Electroslip. Do subscribe, please. Keep supporting. Bye.